Welcome to Lesson 2 in Course 1 Portfolio Theory. In Session 2.1 you will learn the essential tools to determine the proportion of your overall portfolio to devote to risky versus risk-free assets. The learning goals for Session 2.1 are: you should be able to differentiate between speculation and gambling. You know how the concept of risk aversion and its implications. Students should also be able to work with utility function and understand its applications. Speculation versus gambling. It's important to understand the difference between speculation and gambling. We need to know considerable risk, which means the risk level which is sufficient to affect the decision of a person. To gamble, it is to bet on an uncertain outcome. The central difference between gambling and speculation is the lack of a positive risk premium. As previously learned, a positive risk premium results when an expected return is greater than the risk-free alternative. A gamble is the assumption of risk for enjoyment of the risk itself, whereas speculation is undertaken in spite of the risk involved, because one perceives a favorable risk-return trade-off. To turn a gamble into a speculative venture requires an adequate risk premium to compensate risk-averse investors for the risk they bear. A risk premium of zero. If the expected return of an investment equals the risk-free rate, we would have a risk premium of zero. This is called a fair game because there is no expected gain to compensate for the risk entailed. A risk-averse investor will reject gambles, but not necessarily speculative positions. Let's make an example. If Paul plays a game where he wins $10 with a probability of 0.5 and he's gonna lose $10 with a probability of 0.5, his expected return is actually zero. So a risk-averse investor wouldn't do this game. Now, if the game would be different and you would have a probability of 0.7, the chance that you win 10 and only 0.3 that you're going to lose 10, your expected return is actually going to be a positive 4. So you have a risk premium which is greater than zero. Risk aversion. Historical returns on various asset classes analyzed in a mountain of empirical studies leave no doubt that risky assets command a risk premium. This implies that most investors are risk-averse. Investors who are risk-averse reject investment portfolios that are fair games or worse. Risk-averse investors consider only a risk-free or speculative prospects with positive risk premiums. Loosely speaking, a risk-averse investor penalizes the expected rate of return of a risky portfolio by a certain percentage to account for this risk involved. Let's introduce the concept of utility. Intuitively, a portfolio is more attractive when its expected return is higher and its risk is lower. But when risk increases along with return, the most attractive portfolio is not obvious. Therefore, how can an investor quantify the rate at which they are willing to trade off returns against risk? We will assume that each investor can assign a welfare or utility score to competing portfolios on the basis of the expected return and risk of those portfolios. Higher utility values are assigned to portfolios with more attractive risk-return profiles. Portfolios receive higher utility scores for higher expected returns. and lower scores for higher volatility. The utility function. Let's have a look at the utility function, which is defined as follows. U is the utility value and A is an index of the investor's risk aversion. The factor of 0.5 is just a scaling convention. To use this equation, rates of return must be expressed as decimals rather than percentages. Looking at the formula, utility is enhanced by high expected returns and diminished by high risk. Notice that risk-free portfolios with a variance equal to 0 receive a utility score equal to their known rate of returns because there is no penalty for risk. Available risky portfolios. To illustrate the issue we confront when choosing among portfolios with varying degrees of risk, suppose the risk-free rate is 5% and that an investor is comparing the three alternative risky portfolios shown in the table below. The risk premiums and degrees of risks, so-called standard deviation, represent the properties of low-risk short-term bonds L, medium-risk long-term bonds M, and higher-risk large stocks H. Accordingly, these portfolios offer progressively higher risk premiums to compensate for greater risk. As you can see, all three portfolios offer a positive risk premium compared to the risk-free rate of 5%. So the question is, how might investors choose among them? Utility scores of portfolios with varying degrees of risk aversion. To answer the question from the previous slide, we use the utility function and calculate for each investor's risk aversion the utility for portfolio L, M, and H. For each investor type, we would recommend the portfolio with the highest utility. An investor with a risk aversion of 2 would therefore prefer portfolio H, with higher risk composed of large stocks. An investor with risk aversion 5 would prefer portfolio M, composed of medium risk long-term bonds, as this portfolio offers him the highest utility. The same is valid for an investor with a risk aversion of 3.5. We can interpret the utility score of risky portfolios as a certainty equivalent rate of return. The certainty equivalent is the rate that a risk-free investment would need to offer to provide the same utility score as the risky portfolio. The certainty equivalent rate of return is a natural way to compare the utility values of competing portfolios. Given that all calculated utility values are greater than the risk-free rate of 5%, all three investors would prefer to invest in a portfolio with some risk versus a risk-free investment. Let's have a look at the different investor types. As shown in the previous example, investors with different risk aversion prefer different portfolios. Risk-averse investors with A larger than 0 ask for an increased risk premium for increasing risk. Their marginal increase in utility is decreasing as risk increases. Risk-neutral investors with A equal to 0 judge risky prospects solely by their expected rates of returns. The level or risk is irrelevant to the risk-neutral investor, meaning that there is no penalty for risk. His portfolio certainty equivalent rate is simply its expected rate of return. A risk lover with A smaller than 0 is happy to engage in affair gambles and games. This investor adjusts the expected return upwards to take into account the fund and confronting the prospect's risks. Risk lovers will always take a fair game because their upward adjustments of utility for risk gives the fair game a certainty equivalent that exceeds the alternative of the risk-free investment. Trade-off between risk and return. We can analyze the individual's trade-off between risk and return by plotting the characteristics of portfolios that will be equally attractive on a graph with axes measuring the expected value and standard deviation of portfolio returns. The figure below plots the characteristics of one portfolio denoted P. Portfolio P, which has expected returns and standard deviation, is preferred by risk-averse investors to any portfolio in quadrant 4 because its expected return is equal to or greater than any portfolio in that quadrant and its standard deviation is equal to or smaller than any portfolio in that quadrant. Controversially, any portfolio in quadrant 1 dominates portfolio P because its expected return is equal to or greater than P's and its standard deviation is equal to or less than P's. What can be said about portfolios in quadrants 2 and 3? The desirability of portfolios in quadrants 2 and 3 from the previous graph compared with P depends on the degree of the investor's risk aversion. Suppose an investor identifies all portfolios that are equally attractive as portfolio P. Starting at P, an increase in standard deviation lowers utility. It must be compensated for by an increase in expected return. Indifference curve. Let's focus on quadrants 3 and 2. Continuing on the discussion of the previous slide, on the graph below, point Q is equally desirable to these investors as P. Investors will be equally attracted to portfolios with high risk and high expected returns as to portfolios with lower risk but lower expected returns. These equally preferred portfolios will lie in the mean standard deviation plan, and the curve is called the indifference curve, which connects all portfolio points with the same utility. Note that each portfolio offers identical utility because the portfolios with higher expected returns also have higher risks. The mean variance criterion. As previously discussed, the trade-off between risk and return. It can be stated that portfolio X dominates portfolio Y if the expected return X is larger or equal than the expected return of Y, and if the standard deviation of X is smaller or equal to the standard deviation of Y, and at least one inequality is strict to rule out indifferences between the two portfolios. As previously seen in the graph with quadrant 1, the preferred direction is northwest, because in this direction we simultaneously increase the expected return and decrease the volatility of the rate of returns. Estimating risk aversion. How can we estimate the levels of risk aversion of individual investors? A number of methods may be used. One is the questionnaire, which can distinguish between high, medium, or low levels of risk aversion coefficients. Access to the investment accounts of active investors would provide observations of how portfolio composition changes over time. Coupling this information with estimates of the risk and return of these positions would in principle allow us to infer investors' risk aversion coefficient. Finally, researchers tracked behavior of groups of individuals to obtain average degrees of risk aversion. We are at the end of session 2.1. After having carefully studied the slides and relevant chapters in the book, please start with the review questions.